we'd just like to acknowledge the traditional owners of the country throughout Australia and their continuing connection to land, sea and community. We pay our respect to them and their cultures and to the elders past and present. Thank you. And good afternoon or morning, depending on your time zone. Welcome to this webinar featuring aviation forecasters from the Bureau of Meteorology. My name's Terry Horsam. I'm an aviation safety advisor with CASA, and I'll be facilitating today's webinar. Now, before we start, just a couple of housekeeping items to remind us of the protocols when using Teams, if you haven't done so for a while. If we can ensure that our cameras are actually turned off and our microphones are muted, that'll give us the bandwidth required for everybody today. The way the presentation will work today, we're going to allocate some time for questions at the end of the briefing from the Bureau. And if you have questions during the presentation, you may find that they are answered as we progress, or alternately, you can use the chat function, which is monitored and answered at the end. This presentation will be recorded and will be made available on the CASA Pilot Hub, so you can review this or recommend it to fellow pilots. So your safety is in your hands, weather and forecasting for the GAF and the TAF. My name's Terry Horsam. I'm an aviation safety advisor with CASA, and joining us today we have Sarah and Ben, who are both aviation meteorologists with the Bureau of Meteorology. On behalf of everyone at CASA, Sarah and Ben, thank you very much for taking time out of your busy schedules to enable us to present today. A little bit of a word from our sponsor today, and as you'll see, we've got a digital badge which is available at the conclusion of today's presentation. And this is to recognise your commitment to aviation safety by attending these important safety educational briefings, and we're going to include a link to the details for the digital badge at the end of the webinar. I'm going to start off a little bit, just again continuing on words from our sponsor, and before we get into the presentation from the Bureau, just a couple of reminders for us as pilots in command. If we're going to conduct our flight safely, most of you will be familiar now with the CASA Part 91, which has come into effect within the last 18 months. Nothing's really changed here, but there are some rules and regulations that we just want to make sure that you're aware of when we start going through our presentation today. The rules say that you must study the authorised weather forecasts and reports for the route and for the departure and planned destination and any planned alternate aerodrome to be used. This information is contained in the Manual of Standards, Part 7.02. And another thing that we just want to make sure that everybody's familiar with is timing on your weather reports. Most of us, when we go flying, will probably start looking at the weather forecast a few days in advance. We may even have a look at the Channel 7 weather forecast the night before. That's all well and good, but the requirements are that the authorised forecast must cover the whole period of the flight and include a wind and temperature forecast, and especially for flights at or below 10,000 feet, a graphical area forecast is required. You must update the forecast before departure if you obtained the forecast more than 1 hour before takeoff. So there's just a few reminders for planning. And even if we didn't have these rules in place, it's actually really good threat and error management practice to ensure that you are leaving with the most up-to-date weather. We know things can change quite quickly when it comes to the weather. So without further ado, I'm going to hand over to our two meteorologists from the Bureau. And without further ado, if Sarah and Ben, you'd like to take control.
Thanks for that, Terry. Just bear with me. Okay, so welcome to this presentation on GAF and TAF interpretation. If you could take a moment to scan the QR code and leave us some feedback at the end, that would be greatly appreciated. We'd also like to hear from you to learn what you'd like to learn more about, as that will inform future presentations. So today we'll be covering GAFs, TAFs, and we'll take questions at the end. So a quick overview of the forecasting centres. So our aviation centre is divided into 3 teams. So we have the Melbourne AFC. So we look after WA South, South Australia, Victoria and Tasmania. The Brisbane AFC, who looks after WA North, the Northern Territory, Queensland North, Queensland South and New South Wales East. And then we also have the Hazardous Weather Unit located in Melbourne, which looks after New South Wales West en route above 10,000 feet forecasts, and they issue volcanic and ash advisories and space weather advisories too. So myself and Ben are located within the Melbourne AFC. And I'll hand over to Ben now, who's going to talk about GAFs.
Thanks, Sarah. Thanks for coming, everyone. So we'll get started with GAFs. Some of you may have seen them and some of you may have not. There's plenty of information out online, and we'll share that at the end of the presentation as well to help you find some of the more technical details. But we can start with just some basics of the GAF. So we can see that the GAF is broken up into several segments. We've got the picture, we've got some texts, and just some general information around it. Within the text, that's we have sub areas within the picture, and those areas are in the text, and they help you identify what areas will see what kind of weather over your period. So we're issuing GAFs for the next 12 hours at 5Z, 11Z, 17 and 23Z, valid for 6 hours. Within that GAF, we have cloud, which we can see here. We have things like what kind of weather we're going to experience, such as showers or thunderstorms or maybe dust. We have the surface visibility that's associated with those showers or storms. We also have any turbulence that you may encounter, such as just regular turbulence or perhaps even mountain waves. And we'll also describe what the freezing level is, if there are any freezing layers, and how those change over time. Now, the GAF is subject to continuous weather watch, which means we're always checking it. However, we will not update it to make things worse if they are worse than what we have given on our GAF, which means you need to always be checking your air mets, which will be covering any deteriorating conditions. We can issue corrections, however. They are reserved for only improved conditions. Say we have showers coming off a lot earlier than we thought they were going to. We might issue a correction. So when we're reading a GAF, there are really 2 main areas within each area that you're looking at. The top box here is describing the prevailing conditions. This is what you're likely to experience for the route for the majority of time that you're flying in it. And then we have the weather phenomena below it. This is what you may experience worse conditions in, such as the showers, storms, or dust or other phenomena. So I'm going to take you through a GAF construction process. This is how we would create one, or an example of how we might. It's a very rough and ready example, and there's a lot of information that goes into it and a lot of decisions that get made. But just so to give you an idea of roughly what we do, we're going to run through it now. We take in some observations, we include model data, and we apply our own local knowledge that we've gained over years of experience. We're also taking into account things like model variation, because we don't just use one model. When you open up a provider such as Windy, you might just see the first one there. That's just one of many models that you can use. We're also taking into account a bit of a balance between how readable is the GAF and how accurate and detailed is the GAF. So starting with observations, we use things like automatic weather stations, such as this one here in Hobart, atmospheric soundings, which is a balloon launch and tells us what the atmosphere looks like above the station. We have satellite imagery updated every 10 minutes to give us a broad overview, and also radar, which is obviously showing us where precipitation is falling. So we'll go through a quick example now of constructing a GAF. In this example, for Tasmania, we have a low pressure system to the south and a fast moving cold front approaching from the west. You can also see there a prefrontal trough across the Bass Strait extending up through Victoria and into central Australia. And that's going to be the main feature of our GAF construction today. So starting off with what we see from when we first open up our GAF, it's just a blank screen like this. And we're going to overlay something on the left, which we've got cloud coverage and cloud bases here. It's basically showing us the height above sea level that we're seeing cloud or expected to see the cloud at a certain time step in the day. So we're using that to broadly break up our area into three main features. We're starting off by identifying our cold front there through the west. On the very left of the GAF area, you can see a blue line with triangles on it. That's our cold front moving in. And it moves out in the next 6 hours into central Tasmania. So here we see we've divided up our GAF into three different areas, A, B, and C. A is where our cold front is progressing and the weather associated with that cold front. B is pre-frontal air mass. We're seeing some low cloud up there through the north, identified by some of those more yellowy, orangey colours. And out through C, there's some cloud around, but it's not too low. It's very pre-trough, and you're not expecting too much severe weather in that area. Next, we're going to identify what our weather phenomena is. And in this case, with the cold front crossing Tasmania, one of our biggest issues here is rainfall. So we've overlaid precipitation across Tasmania, highlighted on the graphic there by some light yellows and greens. So this is the rainfall in the 6 hours to the end of the GAF period. So essentially we can see anywhere where this model expects that rainfall might be. And though, especially through area A, we can see quite a broad area of precipitation falling. And so we've identified scattered showers in that area, as shown on the right in the text. Through area B, our prefrontal area, we've also identified some showers up through the north in the Bass Strait and out through the southeast. So we've identified some 5,000 metre isolated showers. And out through C as well, there's a weak band ahead of that trough, which we've also put as isolated showers, with some isolated TCU accompanying that cloud. Now, there's many things that we're checking to define what we're calling scattered or isolated or even TCU, but this is just an example to show you exactly how we're placing those areas. Next, we've broken up into sub-areas because not all of Area B is actually seeing rainfall. Much of the Midlands, northern coastline and the Far East is not seeing rainfall. So in the text on the right, you can see we've said isolated showers B1, B2 now. What that's telling you is, although B is the same area, it's only B1 and B2 which will be seeing any shower activity in that area. So if you were concerned with shower activity dropping down 5,000 metre visibility, you might know to avoid B1 and B2 and be safe in B. Next, we're looking at the low cloud and timings of any of that cloud and precip coming in. So as we can see here, there's rainfall in the 1 hour to 13Z on the left in the graphic, that frontal band moving onto the west coast. We're identifying that that's clearing off to the east as it moves across. So you can see that we've added in this area here. We've got showers developing in area C from 12Z as it moves across. And then as it finally starts to leave, we've identified area A1 as a clearance zone. So now we've been able to say that the rainfall will stop in A1 at 13Z there, as shown on the blue arrows. The same goes with the cloud. We've decided that the broken cumulus and stratocumulus at 3,000 foot is clearing to scattered from 13Z as that cold front starts to move out. Note that the cold front is still in the same area. That's just what it was at 11Z, but the rainfall we're seeing moving out. We continue with our timings, looking at other areas such as Area B. We've got that low cloud scattered stratus of 1,000 foot C in B2. That's really just describing that it's not all through B2, it's just in the C area until 15Z is saying that it's clearing off by 15Z. So we're forecasting that after 15Z, we shouldn't be seeing any scattered stratus anywhere in B, let alone in B2. We're also describing this clearance from A1 here, ceasing A1 from 13Z. Essentially, we're saying that it's gone from A1 at 13Z. You might note that we also have an isolated from 15Z. So 3,000 metre scattered showers isolated from 15Z, because what we've seen is that frontal band really start to break up as it moves over the western tiers of Tasmania. If I just jump back 2 hours there, we can see how well structured that is. Lots of rainfall falling, scattered showers in that A area. But again, by 15Z, 16Z, the rainfall's really broken up and we're only saying it will be isolated showers. Now, the difference between isolated and scattered is a percentage of the coverage of that total area. So we define isolated as seeing visibility reductions down to, say, that 3,000 metre mark, covering up to 50% of the entire A area. When we say scattered, we're saying 50 to 75% of that area will be seeing visibility reductions. And if we say widespread, it's above 75%. That's to help you describe whether you might feel comfortable with the 3,000 metre visibility if you know it will only be affecting small areas of the entire area A, or maybe if it's scattered, you're not comfortable flying in a 50% coverage of 3,000 metres, as you might not be able to find any gaps. One of the last things we're adding here is our turbulence. So I've overlaid this wind map. The colours are showing the wind strength and the wind direction here, where the blues are stronger winds, the greens are medium strength, and the yellows are much lighter. We roughly define moderate turbulence as winds of 25 to 30 knots at ridgetop height, with severe turbulence 45 to 50 knots or above. And as we can see here, we've added in moderate turbulence below 7,000 feet in the land area only, east of Wynyard to Matsuyker Island. And we've also described a severe section in A2 now. We're also describing the same area with moderate mountain waves. And in Area B, it's very similar, but we've described that south of just the far northern extent of the island. So this is what our NGAF is starting to look like. You notice we have our cloud, our weather phenomena, our turbulence in there. We're just missing our freezing levels. So we can look at that with another map to describe what we have, where in this case, we can see that the cold front is starting to bring in some cool air in through the south, above 10,000 feet through the north in A, and 6,000 feet in the south in A. And similarly for B2, we see that cold air of 7,000 foot freezing level moving into B2 after 15Z. Now, a lot of this is very confusing, and for some of you may have never seen the GAF before. There is a bar down there in the bottom left that describes the number that you can ring for that specific GAF area. If you call that, you'll talk to someone like Sarah or myself, the person who has written that GAF for the day, and we can run you through exactly why we've put down what we've put down, any explanations of why we've done it, or even just describing what the actual GAF is saying in its own if you're not familiar with the product. There are some more resources available for you because I haven't gone through exactly what the GAF, all the details of the GAF. There's a lot to talk about with it. So there are some reference cards such as this one in the Knowledge Centre of the Bureau's Aviation webpage. It's going to give you a list of descriptive terms that we might put in that you aren't familiar with, and just generally how the structure of the GAF is. Otherwise, feel free to go to the Aviation page and click on the About Graphical Area Forecast button, and you'll bring up a whole lot of information here that you can access. The Graphical Area Forecast user guide is fantastic, as is the questions and answers, but there's plenty more information there to help you understand exactly how a GAF operates. So thanks for listening to me talk about GAFs. I'm going to hand it back to Sarah now to talk about TAFs.
So just some TAF basics to start. So the TAF describes the meteorological conditions expected within a 5 nautical mile radius of the aerodrome reference point. This is actually changing to an 8-kilometre radius, though, from the 30th of November. The TAF validity and frequency of issuance depends on the type of aerodrome. They're generally issued 6 to 12 hourly and valid between 6 to 30 hours. But again, it depends on whether they're category A, B, C, or D. Forecast elements include wind, horizontal surface visibility, sometimes vertical visibility, weather, and cloud. And like GAFs, TAFs are subject to continuous weather watch and review. We issue TAF amendments to reflect the latest expectation in conditions and TAF corrections for typographical errors. So I'll start with an example TAF and I'll explain the basic structure. So the first line is the TAF header, TAF to indicate that it's an aerodrome forecast. The ICAO code for the location, so this is a Melbourne Tullamarine TAF. The time that the TAF was issued, this TAF was issued at 23:15 Zulu on the 8th day of the month. And then the time that the TAF is valid. This TAF is valid between 00Z on the 9th and 06Z on the 10th. We then have the prevailing conditions, which are valid from the time that the TAF is valid, followed by change groups, which are from or becoming lines. indicating how the mean conditions will change throughout the TAF period. We then have variation groups. These are inters and tempos, and they describe how the weather might deteriorate for periods of up to 60 minutes. Then we have variation groups with probability, followed by a remark section that contains information about turbulence, temperature, and QNH. So a refresher on the winds, direction is given in degrees true, and we forecast the maximum wind speed when we expect it to exceed the mean speed by 10 knots or more, or when operationally significant. So the prevailing conditions from the Melbourne TAF, we have direction from 20 degrees true, so it's a north-northeasterly, mean speed of 15 knots, and maximum gusts of 30 knots. So when we expect the speed to be 3 knots or less, we forecast variable direction, and we also forecast variable direction when the direction cannot be realistically forecast, as in the case of thunderstorm downbursts. And there's an example of what that might look like on a TAF. So how do we forecast winds? So the top plot shows a model-generated time series of how winds are changing in speed and direction with height over time in the atmosphere, and the coloured contours are relative humidity. So we might forecast a wind change where the winds at the surface are shifting from a southeasterly to a northwesterly. And the bottom plot shows multiple runs from the same model. This is from our high resolution model. And where there's less variability between the model runs, there's more certainty that something will happen. And where there's more variability, there's less certainty that something will happen, less consensus between the runs. So we might be confident forecasting wind gusts between 15 Zulu and approximately 6 Zulu, where there's good model consensus that gusts up to 30 to 35 knots could occur. And using this as a way of forecasting wind gusts for a point location generally verifies quite well. So weather is forecast using abbreviations. In green, you can see the various weather phenomena that we include on the TAF and the associated abbreviations we use for those. We include intensity with precipitation, dust storms, sandstorms, and funnel clouds. So a minus sign for light, no qualifier for moderate, and a plus sign for heavy. And we also include descriptors where appropriate. So from our Melbourne TAF, we can see in the prevailing conditions, we have light showers of rain. In the inter, we have heavy showers of rain. In the Prob 40, we have thunderstorms of rain. And in the Prob 30, we have fog. We also write NSW when we're going from a change group with weather to a change group with no weather. And NSW literally stands for nil significant weather. And we use CAV-OK when we expect that the visibility will be greater than 10 kilometres and there will be no weather or cloud of significance. So cloud, we only include cloud with bases at or below 5,000 feet or the highest 25 nautical mile minimum sector altitude. The exception being cumulonimbus and towering cumulus, which we include regardless of the height of the base if we're expecting those. When we're not expecting cloud of operational significance, but CAV-OK is not appropriate, we write NSC for nil significant cloud as an example of what that might look like on a TAF. And you might see something like this in the event of high base showers or rain, where we're expecting light showers to reach the surface, but the cloud base to remain above 5,000 feet. So the table to the left shows the various codes that we use and the associated cloud amounts. We use few for 1 to 2 octaves, scattered for 3 to 4, broken for 5 to 7, and overcast for 8. And we don't include cloud type unless we're referencing cumulonimbus and towering cumulus. So CB for cumulonimbus and TCU for towering cumulus. So in our Melbourne TAF, we can see in the prevailing conditions, we have scattered 1,000 foot cloud and broken 2,000 foot cloud. And in the Prob 40 for thunderstorms, we have cloud reducing to broken at 800 feet and scattered cumulonimbus at 4,000 feet. So how do we forecast cloud? So as Ben mentioned earlier, these are profiles of the atmosphere. The left image shows 4 profiles overlaid, 3 model generated, and the actual observed sounding for that location taken with a weather balloon in black. And on the right, we just have 2 model profiles overlaid. So looking to the image, the right part of each profile shows the temperature and the left part shows the dew point temperature. And so where they're coming together, this is indicative of moisture in the atmosphere. So looking to the left image, you can see that we have a shallow layer of moisture that starts at about 900 hectopascals. So this cloud base would be sitting at about 3,000 feet above sea level. This is like a classic stratocumulus trace. And on the right, we have a deeper layer of moisture extending about 7,000 feet. And this is likely a cumulus trace. So when we're forecasting visibility, we write 999 when we expect that the visibility will be greater than 10 kilometres. And when we're thinking about which visibility to use for precipitation, we're thinking about things like the size of the water droplets, the depth of the moisture, the height of the cloud base, and the cloud type. However, when forecasting fog, we're always forecasting visibility below 1,000 metres. So for vertical visibility, we're only including vertical visibility on the TAF when we expect that the sky will be obscured by smoke, and it's limited to smoke events where the base of the smoke layer drops below 5,000 feet. So this is what it might look like on a TAF. This TAF is from East Sail. In the prevailing conditions, we have 8,000 metres horizontal surface visibility and 3,000 feet vertical visibility. And in the Prop 30, we have the horizontal surface visibility reducing to 5,000 metres and the vertical visibility reducing to 2,500 feet. So change groups, which are from and becoming lines. So when do we use from and when do we use becoming? So we use from when we expect that the conditions are going to change rapidly to a different set of conditions on the hour. So from our Melbourne TAF, we can see that from 08Z, the winds are shifting from a north-northeasterly to a westerly, the gusts are easing, the light showers are ceasing, and the cloud is lifting and breaking up. We use becoming when we expect that the conditions will change at an unspecified rate and an unspecified time over a given period of 1 to 2 hours. So it might look like this on a TAF where we have broken 500-foot cloud, and over the period 00 to 01, the cloud lifts to 1,000 feet and becomes scattered. So you might see something like this on a TAF where we've had low cloud that's formed overnight or in the early hours of the morning. And after the sun rises and we get a bit of surface heating, the cloud lifts and breaks up. So variation groups, which are inters and tempos. So inters describe deteriorations in conditions that could last for periods less than 30 minutes. And tempos describe variations that could last longer than 30 minutes but less than 60 minutes. If we expect the variation will last longer than 60 minutes, we use a from or becoming line. So how do we forecast inter versus tempo? When we're thinking about precipitation, we're usually thinking about the type of weather system and the strength of the steering flow. So a fast-moving cold front would be more likely to produce inter conditions for showers and rain, whereas a slow-moving cold front may be more likely to produce tempo conditions. So probability forecasts. We only use them with reference to thunderstorms or poor visibility resulting from fog, mist, dust, smoke, or sand, and only when the estimated probability of occurrence is 30 or 40%. If we expect it to be greater than 50%, we don't use a probability, it goes straight onto the TAF as an inter-tempo or into the mean conditions. So one way of thinking about probabilities is that the forecaster is 100% confident that there is a 3 out of 10 chance or a 4 out of 10 chance of that thing occurring. There'll actually be a webinar that focuses solely on probability forecasting in November, so stay tuned for that. So turbulence. Turbulence on the TAF references turbulence other than that associated with convective cloud like cumulonimbus and tower and cumulus, and we only forecast for moderate or severe turbulence. So this animation shows the Victoria area. We've got some strong winds which are roughly perpendicular to the Great Dividing Range. The stronger winds are shown in red and blue, and for locations downstream of those strong winds, downstream of the ranges, we might forecast severe turbulence tending moderate. And so when we are forecasting turbulence on the TAF, we are thinking about things like the proximity of the location to topography and the kinds of wind regimes it's susceptible to turbulence in. And for aerodromes that don't receive wind shear warnings, we're thinking about things like significant wind shear as well. So temperature and QNH are given at 3-hour intervals for a maximum of 9 hours. And it's up to you to use linear interpolation to determine the values in between those given. So if you scan the QR code or follow that link there, that will give you access to our Aviation Knowledge Centre that Ben mentioned earlier. It contains a plethora of resources about the different forecasts that we write, as well as information sheets specifically on the GAF and TAF. So we'll finish with the GAF TAF frequently asked question. So how can a weather element be present in an area but not be forecast on a TAF in that area? So that GAF there is valid between 11 to 17 Zulu. The area highlighted in blue, Area C, contains isolated thunderstorms of rain, and Kalgoorlie is also located within that area. But there are no storms forecast on the Kalgoorlie TAF between 11 and 17 Zulu. So why is that? So the image to the right shows a satellite picture of what actually happened, and the closest strike was west of Kalgoorlie, approximately 25 nautical miles away. So it's worth keeping in mind that that Area C on the GAF actually encompasses 80,000 nautical miles squared, while the TAF area is equivalent to 80 nautical miles squared, which is only 0.1% of the total GAF area. So the GAF is really a worst case scenario of what could happen. And it's possible that the forecaster on that day deemed there to be a 10 to 20% chance of storms at Kalgoorlie, but it wasn't quite a Prob 30. So we do offer a phone briefing service, and Ben mentioned that earlier as well. So you can give us a call. We can provide you with more clarification or detail, give you a longer range outlook about the weather, provide you with the latest observations, or you could point out any errors should you stumble upon them. We need to know the time that you're interested in flying, as well as the start and end location and any key locations along the route, as well as operationally significant criteria. We do have a few periods on shift that are particularly busy. So this is 7 a.m. and 7 p.m. local time in Melbourne and Brisbane. And the oncoming forecaster may require about 30 minutes to set themselves up and familiarise themselves with the weather situation as well as the current forecasts. And we're also busy at 05, 11, 17 and 23 Zulu, as we're preparing our Category A TAFs at this time, and they're one of our higher priority products. So again, if you could scan the QR code and leave us some feedback, we'd really appreciate that. Hopefully you enjoy this presentation and learn something today. Thank you.
That's great. Thank you, both Sarah and Ben. That's been really enlightening today. As we move on, we've got a couple of questions. If you've got some time, we hope to keep this down to about a 45-minute session, which is always very difficult when we're talking about things like forecasting. You may not be able to answer these couple of questions that we've received, but I'll put them to you anyway. One from Cameron, and his question was that I've never seen fronts depicted on the Victorian GAF from the day GAFs were introduced. Any reason for that?
With the Victorian GAF, it's quite a busy desk. It has, I think, 20 TAFs to produce, as well as your 2 GAFs, the Melbourne TAF, and we field probably the highest frequency of phone calls on the Victorian desk that we do compared to most other desks, if not all of them. Oftentimes, it's just because the forecaster is very busy. As you say, if there's a cold front moving into the area, it's likely to be associated with a lot of very busy weather and a high workload on the forecaster. Sometimes they might not have time to include things like drawing out the actual cold front, exactly its location and its speed and direction of travel. So the busyness on the desk does sometimes come into account. Some forecasters might not be overly familiar with the importance as well, so we can provide that feedback to some of our colleagues to be sure to use the cold front, especially if it's really handy to you as pilots and you like to know exactly where it is at that time.
That's great. Another question from Barry is, what would you say is the most is the thing people find most confusing about interpreting the GAF?
Do you have an Sarah?
No, I'm not sure what's most common.
I know I understand that cloud heights and coverage is probably one of the highest safety risks for you as pilots. I think that is one of the things that people do have a little bit of troubles with interpreting, to do with the exact timing of that cloud moving in, why it's moving into one area at a certain time and moving out of another area at another time, because some of these features are very transient, such as a cold front. It can be quite hard to understand on the GAF how we're trying to move a cold front across. That is particularly the case in the winter, where we do have fast-moving fronts with very defined lines of precipitation and cloud. And that's why it is best to just give us a call if it's not making much sense to you, because sometimes, as I said earlier, we do leave out detail to make it as readable as possible, in expectation that we might field a few extra calls that day.
Yeah, it is a bit of an art getting the balance right between the amount of detail on the GAF and making it readable. Like, it's quite tricky. So yeah, always good to give us a call for clarification.
That's a great tip. Thanks very much. And yeah, for all of us, I guess we're very grateful that resources available to us when we are planning. A couple of other ones that come in. Again, you might not be able to answer these. I might be able to give a bit of background, but from David, given we are no longer limited to text and facts, why do we still use such encoded, abbreviated weather reporting?
I think it's an ICAO rule. So when we're forecasting, we use a document called the ASH. It's a bureau-made document. It's the Aviation Services Handbook, but it's heavily informed by the ICAO Annex 3, which is basically a bunch of international rules and regulations that we need to follow. So yeah.
Yeah, and from what I found, especially talking to pilots in outback Western Australia, South Australia, they have very low internet bandwidth. We can't relay broad areas of text or graphics very easily to them, and oftentimes it is better to just send it in the briefest, most condensed fashion possible and try and educate everyone on exactly how to read that.
And yeah, I think TAFs have to be coded. So I think GAFs follow a similar fashion, just to have consistency between the products as well.
Yep. Okay. Yeah. Thanks. So, yeah, that's my understanding too. You're the ICAO official weather or authorised weather providers for Australia, and so you have to follow the international ruling. I think though there are some ways of interpreting those weather forecasts in plain English. I know some of the EFB providers do have those available as well. Hopefully that answers your questions, David. This next one, again, might be a little bit out of left field, but given that our navs and instruments are based on magnetic heading, why do we forecast wind on the TAF in true north?
Again, I'm assuming it's an ICAO rule that we're following.
Yeah, Terry, unless you know specifically that one.
No, I would have to go and have a look at that one. I'm not going to try and answer that one off the top of my head, but it's a great question, and I'd say that comes back to international protocols as well. And we've just got a couple more. While we've got a couple of minutes up our sleeve, GAF TAF suggestion just below the contact phone on the GAF. Would it be possible to include a QR code or website link to abbreviations, and that way every GAF and TAF has a link for those unsure of those abbreviations?
Yeah, that's a great idea. We can pass that on to our customer engagement team.
Yeah, thanks for that. I've made a point too, just of noting that there are Bureau information cards that are available through the CASA online store, and they contain all the abbreviations as well. So that might be something to carry around in your nav bag as well. Okay, another one. Do you use pilot reports of cloud, winds, etc. for your observations?
Absolutely. We use any observations we can get in. We strongly encourage any pilot that does call up to tell us what they're seeing in their local area or even what they saw yesterday. Sometimes we speak to the same people day in, day out, and we love it when they tell us exactly how our forecast went from the day before, because it's all a part of fine-tuning our forecasting process as well.
Yeah, and we use observations to ground truth our models as well. So the more observations, the better. They're really useful.
Okay. That's great. There's another question from Iman. Is there a way to overlay aerodromes and other waypoints on the GPWT images when retrieving them from the NAIPS or the BOM.gov? It says he or she says it would make planning much easier compared to switching between GPWT and the reference PDF. I'm guessing there's a reason why we don't do that.
I'm not sure. We can put it to our services delivery team as well and see if it's beneficial to change that product up to make it as easy to use. Yeah,
I guess the GPWT is already a fairly complex document to have a look at, and if we start putting the waypoints and significant features in there, it might be a little bit difficult to do that. Simon, can you expand on the categorization of TAF /GAF? I'm not too sure on the categorization. I don't. Apart from what you've already described.
Could be referring to saying area A, B, and C on a GAF, I suppose. Or
yeah, I'm not sure what the question's asking.
Okay. Sorry, Simon, we're probably a little bit unsure of that at the moment. If you missed out on the beginning of the webinar, we did go through what the TAF and the GAF covered, so maybe that answers that question. Okay, Sean has one. Isolated in the weather phenomena covers quite a broad area at 50%. Is there a scope to have lower percentages indicated, there, such as 25%, or is there a specific reason for 50%?
Yeah, I mean, that's definitely one, and I've discussed in the office as a forecaster whether 50% is too high for isolated. As the forecaster, obviously this isn't our decision to make, but we do apply the rules to our forecasts. But as I've said, and I know it's a bit of a cop-out once or twice, but I'm more than happy to take that back to our services delivery team and see if there is a better percentage threshold that might be more useful to the pilots.
Right, thanks, Ben. That's the great thing about these webinars, is that we do get a lot of sort of information, a lot of people sort of with various ideas of how we can change things or make things better. And let's face it, we're providing a service for all the pilots out there. Zane, yes, the presentation will be available at a later date as a recording. Can you show the QR codes again? Not too sure if we can go back to those just at the moment. Rod, based at Goolwa, south of Adelaide, on the coast. Infrequently we get sea fog roll in, normally in the afternoon, but never seen this on the forecast. I'm guessing that's a difficult one, is it?
Yeah, that's an interesting one. I've never really observed that forecasting for South Australia. Yeah, next time you see it, give us a call if it's not on the GAF and you think it should be.
Yeah, it does sound like a very hyper-localized event, which the satellite can have trouble picking up on because the resolution is roughly, I think, 500 meters in the daytime and 2 kilometers in the nighttime. So if it is a thin band just on the coastline, we might not have any observations or sensors or satellite to be able to observe it. But that's really great to know, actually. Yeah.
Okay, Lawrence says, can we get to the screens you use in making the GAFs? It seemed to include a lot of detail that gets lost by reduction to tabular form.
I think Lawrence might be referring to the model guides that were underlaying beneath the GAF.
I think so.
I think it would be quite complicated to try and combine that with the GAF product because we're loading like multiple different maps underneath. Yeah, that's a tricky one.
Yeah, because at the end of the day, what I had shown in mine was one model called the Access G model. It's by no means going to be the correct model as well. It will be right in some spots and wrong in others, and that's what we as trained forecasters are able to identify. So if we were to just put one model data out there for you to use, there's the risk that unless you're doing your own ground truthing with observations and have experience forecasting and know the local topography quite well, then there could run into issues with getting a forecast wrong because the model got it wrong.
Thanks. We're probably going to have to tidy it up in a moment or two, but there's just a couple here on the same theme, and it's just regarding some of the EFB planning apps that pull a GAF into them automatically. Are these reliable for use within the apps? And does the BOM authorise the use in this way?
I'm not familiar with it myself, Sarah.
Yeah, I'm not really familiar with EFB apps.
Yeah, okay. That comes back to the the answer is yes, you can use them, and air services provide this detail from the BOM, and as we stated earlier, through ICAO ruling, the Bureau are the official weather provider for aviation services within Australia. So the EFB apps use that information, and that makes it okay for you guys to use it. The next one says, how legal are the TAF interpreters if something goes wrong? And I'm assuming that regards the changing from into plain English versions. But again, the official versions or the authorised versions come from the Bureau. Okay, I think probably we're getting towards the end. We do have an answer for the the question regarding true north, and I'm not too sure. I'll just read a couple of them out. True north is constant, magnetic north changes over time. True north makes sense to use that. And just coming through to the end here, we've put the QR code on the chat there. So if anybody's asking for that, we've got that. So thanks, Rick, for putting that up for us. Does the BOM use weather cameras to check forecasts?
Yeah, we do have webcams at multiple locations across the country. And we look at both Bureau owned and external cameras as well.
Yep.
For observations. Yeah.
Fantastic. And I think we're probably getting towards the end of the question. So thanks everybody. We have gone over time here at the moment, but on behalf of CASA, we really want to thank everybody for being part of today's webinar. We are delivering these as part of an education program. It's based on our Your Safety is in Your Hands campaign. And we really do appreciate people sort of logging on, getting some education. And if I can just say once again, thank you very much to our presenters today, Sarah and Ben, because we know you're pretty busy with your job anyway. And it's great to actually see somebody who's providing that detail for us. So thank you, everybody. And please fly safely, and please go to the website to look at the Pilot Hub. And this presentation will be available there within a short period of time. Thank you.
Thanks, everyone. Thanks, Gary.